Good morning, everyone. This is a lecture 3. So, we are going to start with the stability of dam. So, before that, we have found out what are all the forces acting on the dam and what are the types of dam and how to analyze the stresses in the dams. Now, we have to check whether the particular design is stable or not. So for that we are checking in certain conditions. So what are all the conditions the dam may fail? So first one is it may slide over the soil, slide and it will come out. So one is that problem, sliding. So second one is overturning. You can see that some dams can overturn due to the excess horizontal force. Sliding happens when the overall weight of the dam is more and the soil is very weak. Then due to the tensile stress developed, you can see that there is no strong enough, that is a concrete cannot take more tension, so we have to reduce tension as much as possible. And then due to excessive compressive stress, so on the other side there should be no excessive compressive stress. So these are the four conditions at which a dam may fail. So first thing, condition to prevent the sliding of the dam. So at what condition the sliding of the dam will not occur? So in the diagram 10.13, so this is a diagram 10.13, you can see that the same force F, W and R are acting on the dam, and H is the total height of the dam and small h is the height of the water. X is the distance from the from the G point, the point at which the R reacts, that is the resultant force acts, and the total D is the distance from this point to the resultant force acting point. So you can see that this dam is particularly, it should not slide along this side, it should not slide. So what makes this to move along this direction? This resultant force is along the right side, so this dam may uh, slide to the right side. So what is the reaction force? uh, this is a resultant force. For that, the soil will give the reaction force R, which is same magnitude of capital R but on the opposite side. So this force is the resisting force, that is not to slide. So how we can frame this? This R, that is the resultant forces, be given due to the F and W, but this R, that is the resisting R, will be nothing but the force which, so this can be resolved into horizontal and vertical. So only the horizontal component we will take into action, that is due to the frictional force. So F is nothing but mu is nothing but the frictional coefficient between the soil and the dam. So W is the total weight, so F max will be equal to mu into W. So mu is coefficient of friction and W is the total weight of the dam. So this condition must be, that is total, this, what is the this reaction force? You can see that so condition applied that this force, that is this force must be equal to this force, that is the horizontal force, that is F max applied here must be equal to this one or less than the F value, so that it is safe. If F max is lesser than the F, then sure it will start to slide. You can see that the frictional force should be more than the force due to water pressure, that is F. So F value should be lesser than this F max. So this is the condition for sliding. Then condition for preventing the overturning of the dam. So overturning is due to the moment of the forces. Overturning is due to moment of the forces. You can see that about this B point, this total dam shall be, you can see that it will start to rotate like this. It will start to rotate due to this force and this resultant. So how to prevent? We have to calculate the moment values about the B point, so here force due to that is moment due to this force F is force into this perpendicular distance h by 3. So first moment is F into h by 3. So second moment is W into x. So this two must be equal. These two are opposite moment. You can see that this force will create a clockwise moment and this W will create a anti-clockwise about the point B. So here you are going to take the moment, that is F into h by 3, here W into B, that is this is the distance, eccentricity distance or x distance. So about the point M you are taking. So for this W into x, so this is going to be anti-clockwise direction, this is going to be clockwise direction. So these two must be equal for the critical condition. So for that, after rearranging W into, after rearranging you can see that when W into NB is greater than W into X, that is NB value is greater than X, it is stable. What is the NB value? NB, this distance must be, so NB value, that distance must be greater than X. So NB value, the total, the bottom width is should be greater than X. If it is equal to X, it will start to overturn. If it is less than the X, surely the dam will overturn. So this is a condition to be stable for overturning. Then condition to avoid tension. You already know that the sigma max and sigma minimum formula. In that, so this part, this parameters plays a much important role. With this you have to find out. So this parameter should be greater than or equal to 0 for no tension condition. That is, no tension should develop in the dam, so that this 1 minus, because sigma minimum will, you will get a tension stress, so 1 minus sigma E by B should be greater than or equal to 0, or it should not be negative. So in that case, rearranging everything by taking LCM, B minus 6 into E is greater than or equal to 0. So 6E will be less than or equal to B. So B is the total width and 6 times E should be lesser than, or rearranging this also, E should be lesser than or equal to B by 6. E equal to less than or equal to B by 6 for to avoid the tension. So if tension occurs, the dam will start to break. So this is an important condition. Okay, then to avoid excess compression, to avoid excess compression means you have to the maximum stress should be, here it is 1 minus 6E by B. For this 1 plus 6E by B should be the total stress should be within the limit of the breaking stress or crushing stress of the concrete, that is crushing strength of the concrete. So concrete will have some limitations. Thank you.